Hi and welcome. Today we're going to talk about a taint analysis, the second part. Now, the very first video that I uploaded on my channel was about taint analysis, and I kind of figured that I'm going to revisit this topic just a tad more than before and talk about, a few examples and give my thoughts on why this is a really important process for anyone to really be able to perform to the basis of what I'm trying to explain. So I know if you go around and take any taint analysis course online on Coursera, I don't know if I have one, but if I do, it's probably highly technical, lots of graphs and stuff like that. I'm not really a fan of all that because it only complicates the whole process of answering the question, is my code safe or not? So, taint analysis number 2. This is today's video. Let's get cracking. So let's revisit the 3 terms that we're going to use: the source, the sink, and the sanitize/encode, which is just another word for sanitize in this particular example, but I chose to include it because I figured, it's not a bad idea. It will probably help more people to understand what sanitize is all about. The source is the same as the last time. It is still the same. The sink and the sanitize is still the same. Let me just explain it one more time. The source is where data is coming in your code. So you have to let's say 5 lines of code, and you get some input from the outside. Now, it doesn't really matter where that comes from. If it's not from that particular document you're writing, well, then it is a source. But it is up to you to verify whether this data is coming from an included file. Let's say you include a file with some static created data that is like literally created there. Then, of course, it is not a source because it is just something you wrote as a static variable or final variable or a constant value, whatever we're going to call that, right? But as long as that data can change and it's coming from somewhere else, it is just a source, an input of some sort. A sink is where another point of data where data flows to. So in your code, you have, let's say, the 5 lines of code. Wherever you output your file, it could be like to anything basically. It could be to a database. It could be you output data to the front end to a web page. It could be you send data over a socket or network, or the possibilities are in these days more or less endless, but it's a lot of them you can choose. So I'm gonna give you an example later where I talk about sinks and some things that is not really a sink. So sanitize and encode is still the same. It's something you need to do, a process you need to go through with your code before you can send it to the sink. So if it's something that needs to be outputted to, let's say, a user on a front end, let's say that is a web page, then you need to, in most cases, encode or HTML entity or HTML entify your stuff so that if the data you're outputting is not containing any sort of special characters, that can be interpreted by the browser, and then could probably have some cross-scripting or HTML injection or JavaScript injection or whatever you have of bad things going on. That is just for one particular example. There's many different other ways that unsanitized code can have an effect, and this is where you need to verify it. Alright, so let's get ahead and talk about the first one. It's called taint analysis. So let's look at the code here. Let's reflect upon the 4 lines. This is just some pseudocode I found, and I really like this. It's a really good example of source and sinks and taint and everything, what is going on. This is just any kind of basic piece of code you can find in any sort of application, even any web application, any console application, anything that you get some input from somewhere. It could be keyboard input, it could be from a stream you're reading, it could be from the user. It doesn't really matter. It's coming from the outside, as I discussed before. It's just something that is not, typed by you. Okay, so then you have some sort of temporary variable where you put that and you concatenate that to some sort of select. This is obviously a select statement for a MySQL or just any sort of SQL database. And then you have a query execution of this SQL statement, which is obviously also another very simple example of you trying to communicate with the database. And then you have some sort of log here. And until now, we were just looking at it, and it could be many things. This log could be you're logging to a log file, you're writing the raw data to a log file. So is that a problem? Well, it kind of depends what log file you have, because there are some vulnerabilities called log poisoning, and I'm not really gonna go into that. But also, if it's just something you output to the console, let's say this is a test example of code that you are trying out. Let's say you do that in IntelliJ or NetBeans or something like a big program, an IDE, and then you're just logging stuff to the console. Again, this is just pseudocode. There is no function called query or log or anything like that. You can probably find a programming language where there is, but this is just pseudocode that I use for now for the example here. So let's change the slide and identify the source and the sinks. As you can see on line number 1, we have our input, which is a source, and we have the output, which is a sink. So that is the execution of data in the database, which is a source of, a flow going. Our data is flowing away from our source code. That is a sink then. All right. So the question is, what about the log? What about the actual log function called? Now, you can say in this case, this is just a console message, not a direct log file that you write to, and this go right hand in hand with what I mentioned before about if this was, for example, writing to some Apache log file or something. It could be a case of having some log poisoning, and you can get some code execution by that way. But if you just directly write stuff to anywhere, it could be considered as a weakness in your code or a bug or something you need to fix. I wouldn't call it a bug because it's working. It's not generating any sort of syntax errors or runtime problems. It is just unhandled, and that is another way of for many programs to forget, to handle the data, to identify all the places. This is why it is so important when you write some code or you are participating, let's say you're participating writing a bigger framework. This is just 4 lines. Anything can go wrong in these 4 lines. Anything, basically, you can get a whole shell in the box, you can root it, and that's it. So think about all the 100,000 lines of code. Did all the lines go through some sort of, taint analysis process? I really do not think so. This is why I'm just trying to introduce a really simple way you can take with you while you code. Then you can just basically ask yourself, oh, this is a source, this is a sink, I need to do some sanitization or encoding. This is the way you should think every time. Is there an example? Is there a case where you have a source and a sink and you do not need to sanitize? Well, I just from the top of my mind, I cannot. I have no example, but I guess probably. But you should really know. You should really have a good answer for that. You should take your steps carefully if you decide to do that. You should probably not be the only person having that kind of responsibility. But if you are, I know many startups and stuff like that, they do not have these highly paid programmers that got a lot of experience. They just want newly educated people. And depending on which kind of education you took, it's... I would say there's a slim chance that you find these kind of things in like a fast education teaches you how to program. So any professional, you know, it's called academic degrees and stuff like that, they probably do not teach you taint analysis. Just think like this. So this is my take on it, and I really hope you think this is simple and you can use it for something. This is the simple example, and the overall, you know, step-by-step process that you have some input, you put it directly into the query, and that is generating a warning for you. So that is of course bad. So our, as you can see here, we do have some sort of leakage going on, which is really bad, and this is where we didn't do any sanitization or any sort of, you know, encoding. So that would imply to use the safer solution is that your input needs to be sanitized or /encode, and then you can do a query. So if I were to add, let's say, another slide showing how that would be, it would look like this. So then we would basically encode our temporary variable before we put it to the sink. So basically say you have a temp variable, you encode that, and then you send it to the sink, then everything would be okay then. And that would be exactly this figure we have here. We have some input, we sanitize encode, then we query, you have no warning anymore. So basically, you could ask me, how long does it take to perform this kind of, you know, manually taint analysis? How long does it take? Well, if you are the lucky person being handed a 50,000 liner of code, and here you go, this is our legacy code, and you're like, find the box. You are the lucky guy of, I don't know, weeks of work, I guess. There is tools that can help you to verify stuff. You can also try and analyze, you know, the code by doing some, you know, searching through files. If you know already which kind of method you're using, you know, to generate input. If there's some sort of class, you can verify that everything, or function or method, where everything is coming from as input, you can try and search for that and basically just see. But else it is, I'm sorry, something you should do manually. So better do it from the start. It's a lot easier to make it a part of your mindset when you're coding, because then you already, while you're coding, you're thinking about it, and basically you can wrap whatever stuff you have in the correct classes. I once saw a solution with a guy that created some sort of class and said, like, every time I do some sort of input, I include this class, you know, as I extend it, or, you know, and then override some method and give it some standardized names. But it requires you to have some sort of way to code, a standard way of thinking. You really are being, if this is object-oriented programming, it's a lot easier to make these kind of rules and setups in object-oriented programming, because it is kind of what object-oriented programming is all about, you know, in a way that is to reuse and to encapsulate and stuff like that. So let's take another example. This is one called dynamic taint analysis, and we should consider the following code here. We have line number 1, some sort of input, and we have a new variable here on line number 2, and another variable here on line number 3, and we do something with a fourth variable on line number 4, and then we print it to the screen. I assume this is what we're going to do, but basically we need to analyze the flow of the code. Is there any way that, you know, the top here can affect the bottom? So let's look at this. We have our source and the sink in the top and the bottom, and then in between we have the part that you commonly describe as the program algorithm, and I guess you can just call it very simple stuff, but this is nevertheless the program's algorithm. So let's look at this as from a taint perspective. So the first one here, the first line, we are getting some sort of source input from the outside, and we're putting that into the variable x. The variable y is set equal to number 1, which is just another literally typed value, so that does not contain any sort of taint. That is a clear line of code. We can use that anytime, any day. Wouldn't do any harm to our program or our server. Now the c value, however, is equal to x, which is equal to source, so that is just a copy of whatever there is, so that is also containing tainted values. Alright, so then we have the variable called w, and that is equal to y. So y is the value that is no taint, and when you add that to a tainted value, which is equal to c, which is equal to x, which is the source, so it says no taint plus taint, that is equal taint. That's another way of looking at it. So in the end, we execute w, which is tainted. Now you probably think, but what if this is just a simple math thing? How can, when you add the y and the c together, how can that be considered tainted? Well, taint analysis doesn't really concern itself with if this is an exploit or something. It concerns itself with, can I, with the source here from the top line, number 1, affect what's going on in line number 5 in some way that I should not be able to? In this particular case, you can. And of course, you can always ask yourself, well, what if I have some sort of, calculator I created? Well, if you have some sort of calculator you created and the source is the input from the user, and it's the same process you're going through, it's the same mechanism you're going through here, you're identifying what is tainted and what is not tainted. But if you do not sanitize anything, if you do not encode anything for the correct output, the sync, then you do have what we call a leak in your program. This is just another way of you identifying. There could probably be, some sort of use case where it doesn't really matter if the output is looking weird or if it's just output to some direct screen. But then again, think about it this way: if the sync is a screen in a mall, and you can, with the source, give some sort of input that could change the output of the screen, you could in many ways leak, classified information. That is a possible way for you to think about. Sometimes you need to think out of the box. So let's change the slide and do some sort of test here. Now, this is a little special example. I know that you have lines here, so it looks like the lines in between here disappeared. It doesn't really matter. So let's assume that you have this piece of code here, and you have some source equal to x, and you set y equal to x, and you ask if y is equal to 0, set c equals to 2, else set c equal to 1, and then you sync. That is a sync of c. Do we have a data leak here? Is this okay? Are we executing tainted data in some way? Is the sync containing tainted data? That is the question. So I want you to think about this really hard. I know this is a difficult question, and I want to be honest, there are opinions on this, but I'm going to try and give you the most, neutralized version of the response to this. Is there an actual problem with this code? So I'm going to pause the video for just a tad and let you think about it, and then see if you agree with my answer in the end. Alright, so you probably thought about it, and if you are confused about this and what to answer, I understand you, because this is a really interesting situation to be put in. We have no direct source here that we can say c, the variable c is not set equal to any variables that contains our tainted data. From our perspective, we can look at this saying like the first 2 lines are highly tainted. We can all agree to that. But then again, what about the other lines? We do not really have any assignment going on, do we? Now, there's a reason that I said we have really, but there is, and this is called indirectly, and this is why I'm going to talk about this. Look at this chart here. I know that you so like, what? Let me just explain this. The very first 2 lines are probably crystal clear to you that those are tainted. I am agree with you. Those are crystally tainted. Then you have line number 3. You're asking if the tainted value of y is equal to 0. Now, that's not bad, you know, it is just a comparison. It's not execution or the sync. It's just saying like, is this equal to that? Are you larger than that? That is okay. But you're doing on tainted data. So indirectly, the y value's content is being affected to the c value. So if you can affect the y value, you can affect the c value. Can you affect the y value? You can do that in the line number 1 because source is being set equal to x. X is the same as y, and you can, if it says if x equal to 0, it will be exactly the same, no different. So basically, this is actually a really interesting example because you can affect the output even down to the very last line here, marked as line number 7. I know the lines here is not with a number, but yeah, we don't care. We just know what I talk about. The very last line here, called sync C, that is executing or syncing, whatever we're gonna call that. You know, we're putting data through another flow. It is affected by the source. So C's value is affected by a source. Then you can say, but is that really important? If the C value is 2 literal values, are they tainted? Well, not directly, but indirectly they are, because if you can affect it by changing the source, if this is on and off, the 2 triggers on and off, and it's a turbine in a electricity somewhere, you know, generating power for 50,000 homes. If you can change that to turning off, then I would say that's a pretty bad thing. That is called indirect. So the discussion here is that indirect flows can manipulate the data and its outcome. So I know that some might say this is not tainted, and it's not wrong to say that, but it is indirectly tainted. You cannot escape the fact that you can change the outcome or the way this is being used by changing the source. So that was the last slide about taint analysis number 2. I really hope that you liked this one. I gave you something to think about as a programmer. Also, if you're just if you're someone that scripts something, you may be a data scientist, or you're a scientist, or you're a researcher, anyone basically can write code, can create some sort of leak. So I just want to say, think about it. Leave a comment below if you have anything in your mind making this hard to understand, or just suggestions to taint analysis number 3. I would really love to do that. Take care out there.